Good morning everyone. Myself Satyaranjana. I am currently pursuing Integrated MSc Chemistry in NIT Raulkana. I have given the topic equilibrium. Let's start with this topic. Guys, if you listen the word equilibrium, what comes your mind? Which word comes your mind? Any guesses, please? No? Okay. Equilibrium is a word which derived from the Latin. It is a Latin word which means that weight or balance. Let's come to the definition. Equilibrium is a state in condition in which conditions are competing balanced. Means it is the equilibrium is the means the both sides are balanced. Let's take an example at weighing balance. In Hindi we can say that taraju. Then the both sides are balanced. If the both weights are equal, then it will balance. Now the middle portion is equilibrium. That is known as the equilibrium position. Then we can come to the types of equilibrium. There are two types of equilibriums there. One is dynamic equilibrium. And another is static equilibrium. Let's come to the static equilibrium. Static equilibrium means that when the both the are in rest positions. In the let us take an example. Then we can take a scale. Okay, we can take a scale example. If we keep our finger in this position, then the scale move this side. Means in this the force is greater than this one. If we move the finger in this side, then the force is higher. Then it will move this side, downside. If we keep our finger in middle, center of the scale, then it will be fixed. Then there is no movement. Means in this the net force is equal to 0. Let us take example in terazu. Let us say in the weighing machine. Then the both sides are balanced. If we put more weight in this side, then this one is going to downside. If we keep more weight in this side, then it will come downside. If we fix the same amount of same mass, then it will be same balance. Then the middle one is equilibrium positions. Then we can the definition. Let's come to the definition of static equilibrium. In all the examples we saw that all are in rest. That was in static equilibrium. In this all conditions are in rest. So it is called static equilibrium. Then come to the another type of equilibrium, that one is dynamic equilibrium. It is a slight small difference between the static equilibrium. Now in the static equilibrium there is in rest position, but in the dynamic equilibrium it was in movement. Means the conditions of movement. Let's take an example of a shopping mall. Let the capacity of a shopping mall is 50. In the same time, simultaneously, if the capacity of shopping mall is 50 persons, let 10 persons are 10% coming into the shopping mall, and simultaneously 10 persons are exiting in the shopping mall. It is the simultaneous process, but in the main thing is the shopping mall was in equilibrium condition. Means 10 persons are coming into the shopping mall and 10% taking exit from the shopping mall. Then the total capacity of shopping mall is still constant in 50%. That was the shopping mall is in equilibrium position. Let's come to the definition. Dynamic equilibrium is equilibrium in which rate of forward reaction is equal to backward reaction, rate of backward reaction. In the shopping mall, the 10% are going into the shopping mall and 10% taking exit from the shopping mall. That was in dynamic equilibrium. And also dynamic equilibrium are different types. One is physical equilibrium and another is chemical equilibrium. And we tell that the dynamic equilibrium is two types. One is physical equilibrium and another is chemical equilibrium. And here the physical equilibrium are two types. One is phase transformation and another is dissolutions of solid or gas in liquid. What comes to mind when you listen the word phase transformation? Means if we the changing of phase means the changing of phase from solid to liquid and liquid to gas and gas to solid. This was the changing of phase. This comes around also in equilibrium. Let's come to the physical equilibrium and the phase transformation. In the first part of this phase transformation was solid liquid equilibrium. In here the changing of phase between the solid and liquid and the liquid to solid. The changing of phase of the solid to liquid phase, solid to liquid are the rate of melting. Solid to liquid transformation is rate of melting and is equal to the phase changing from liquid to solid was the rate of freezing. Means we take an example of water and ice. The ice is in solid form, which is a liquid water is in liquid form. We can see that the H2O, they are in all three phases: solid phases, liquid phases and gas phases. And solid, this one is ice, and liquid, this one is water, and in gas, this one is vapor. In the solid liquid equilibrium, the rate of melting is equal to rate of freezing. Let's example means if we keep the water at 0 degrees Celsius, then it converted to solid, means ice form. Then we keep the ice in the room temperature, then it automatically converted to liquid form. That means rate of melting equal to rate of freezing. Then come to second part. Second part is liquid to liquid vapor equilibrium. Then the changing of phase between the liquid to vapor and vapor to liquid. The liquid to vapor is the process is called sublimation, and the vapor to liquid is the condensation. In this, rate of sublimation is equal to rate of condensation. So let's take as example, if we heat the water at 100 degrees Celsius, 100 Celsius, then the water changes to vapor. If we keep that vapor in a container, then it will it automatically converted to liquid, means it converted to water form. That means that rate of sublimation is equal to rate of condensation. Then in all three, in these two are in the equilibrium. Then let us take another type is solid vapor equilibrium. Let us take an example of camphor. Camphor means in Hindi we can simply tell that karpur. Okay, if we heat that karpur means if we heat that camphor, then it will automatically it will be changes to vapor. If we then decomposes the vapor, then it will convert it to solid again. That's why the phase changes to solid to vapor and phase changes to vapor to solid. The solid to vapor changes is rate of evaporation is equal to the vapor to solid. The process is called deposition. Rate of deposition. As in all the three phases of equilibrium all these are in equilibrium phases. Equilibrium. Then let's take up another type is called dissolution of solid or gas in liquid stage. Let's take the another type of dissolution of solid in liquids. This is very, very important. We can take the simply example of sugar and water. If we add a pinch of sugar, means a spoon of sugar in water, it is easily evaporate, easily melt in the water. If you take a cup of sugar in a small amount of water, then it will not dissolve. Actually, what happens if in a small spoon of sugar, then it will be completely dissolved. Then if we will add the cup of sugar, then it will not dissolve. That was in dissolution solid in liquids. Sure. In this, rate of dissolution of sugar is equal to rate of crystallization of sugar. Means if we the more water more sugar which we add to the small half glass of water, then the some amount of sugar will be crystallized. Next go to the next part, dissolution of gas in liquids. Have you ever drink the Sprite, Coca-Cola, means thumbs up, cold drinks part? Have you ever drink? If it is a complete sealed bottle, then it will not. If we can see the bubble actually. If we open the seal, then use some shake type, then it will the automatic the bubbles are coming. We can know that the bubbles are in carbon dioxide. But why this happens? I mean, inside the bottle, if we didn't open the seal, then no bubbles form. If we open the seal, then the simply put on the glass, then the bubble arises. Why this? It is due to the pressure change and solubility of gas already changes. That's why dissolution of gas in liquids these are also in equilibrium. Let's come to the characteristics of equilibrium. This physical equilibrium. These all the physical equilibrium are in a closed space. They all happens are in closed space. First thing you can see that they're only in closed space. And the second one is all the measurable conditions. Means all the conditions, the temperature, pressure are remain constant. All measurable conditions are remain constant. And the third point is it is in stable dynamic equilibrium. The third point is stable dynamic equilibrium. This one is the characteristics of physical equilibrium. Let's come to the part chemical equilibrium. Chemical equilibrium. It is a chemical equilibrium means it is a reversible reaction. Means if we take an example a reaction that A plus B, these symbols for reversible reaction. Means the reactant is going to product, and product can be come to reactant also. This one is reactant side, this one is the reactant side, this one is product side. In this, the rate of forward reaction is equal to rate of backward reaction. We can simply see that there is a chemical equilibrium. If the amount of the reactants is going to react product and the amount of product is going to coming to reactant, that one is known as chemical equilibrium. Means rate of forward reaction. Forward means reactant to product side is equal to rate of backward reaction. Means backward means the product side to reactant side. That is known as chemical equilibrium. Let's come to the next part, the law of equilibrium. The law of equilibrium. It means that if the ratio of the rate of forward reaction and the rate of the backward reaction is a constant, that is known as the law of equilibrium. You can simply understand by simple example. Like A plus B, it is a reversible reaction. Every equilibrium is a reversible reaction. You can simply the A plus B equal to C plus D. The rate of forward reaction, I said that before that the forward reaction means the reactant side to product side, and the backward reaction is the product side to reactant side. This one is backward and this one forward. Okay, the ratio of the rate of forward reaction. The rate of forward reaction, we can simply say that the K value is equal to, forward means Kf. We can simply denote that Kf means forward reaction, rate of forward reaction. Okay, the Kf equal to molar concentration of A, molar concentration of B. Then this one is K1, and the rate of backward reaction, let it denoted as K2. The K2 is Kfb, means the rate of backward reaction, then the concentration of C and concentration of D. We can take the ratio that K1 by K2, that is equal to 1. Okay, Kf by Kb equal to AB, C, D is equal to 1. We can take the constant Kf by Kb, which one is Kc, which is equilibrium constant, which we can denote it is a constant. That's why we take another Kc, which is Kc rate of constant, equilibrium constant. That one is denoted. This one is come the numerator side. This one come the denominator side. C D by A B means this one is the product side. This one is the reactant side. Then the multiplication of the molar concentration of the product side divided by the molar concentration, multiplication of the molar concentration of the reactant side is our equilibrium constant.